Okay, record on this computer. Okay, we just started the recording. This is our Sovrin Meetup for August 9th, 2019. I'll be presenting today on the test tokens, auth rules, and transaction author agreement. How are we going to use these new features? So one thing that says standard disclaimer goes here. I'm going to be talking about testing tokens today. We are testing out the option of adding some tokens as payment to our mainnet. I don't know when we're going to do that, or there's been no official announcements for any of that kind of thing. So any kind of speculation on that would be inappropriate on my part or on your part. So if I say tokens instead of test tokens, all I'm really talking about is test tokens for our testing networks. And as we prepare for the possibility that we'll be releasing some tokens at some time. So is that enough of a disclaimer, Nathan? Okay. So before we get into the other stuff, give you a high-level, idea about what has to happen before you do any of the stuff I'm going to be talking about today. There's some pretty good documentation, so I'm not going to go over details on setting up your own local network. Before it gets to the parts I'm going to be talking about. The parts I'll be talking about are new things. All the old stuff is pretty well covered. And so essentially to do that, I just Googled around the other day and I found this first link here. Let me double check and make sure I'm not muted. Nope, I'm not muted. Sorry about that. Back to. Are you sure you're recording? Yeah, I see it. Oh, crud. I'm gonna get back to the presentation now. Sorry about that. Okay, so I Googled around the other day and found a guy that said the stuff on GitHub, the readmes are kind of hard to follow. Here's some more, English type, in step-by-step setup. It looked pretty good, so I put that in here as a link on the top. All I did is Google for, setting up local indie nodes, something like that, and came up with a couple of guys that had done that. So this is a community effort. And so the GitHub stuff is here as well, though. It would be more the official version type of stuff, and it might have more links in it to other parts of things as you get more interested. So that's what that's why I put this slide in here, so that you have the ability to get this stuff. And what I need to do probably is take down your. Can you get a notepad and have them write down their email addresses so I can send you a link to the slide deck. You'll need a link to it because there's a lot of links in here, and I'll be covering from a much higher level than what it would take to go through and tell you everything. So I'll have you write down your email addresses and share this. So essentially that's what you have to do. Essentially step one, go through the regular stuff in here to set up your own local nodes. What the other part of what I'll be going over today is as I explain how to set it up on a network, I'll also be saying how to use it afterwards. And so if you don't want to set up your own local network, you just want to use our BuilderNet, one of our testing networks, to try this stuff out. Some of those instructions will be in my presentation today as well. So we'll just dig right in, and item number one is the transaction author agreement. and I've asked Adam to be here. He'd probably leave right after we're done, but I'm going to have him tell us a little bit about the, how do I do this bigger? No, that wasn't it. Is that big enough?
Just about.
Adam will tell us just a little. He wrote this blog post, and he knows a little bit more about the basics and what the transaction author agreement is, etc.
Yes, thank you, Lynn. I want to make sure we all are aware of just the basic use case of the Sovrin Ledger. Are there any questions around that, or do you need an elevator pitch type of intro?
I don't think so.
So you're good? Okay, so Sovrin is striving to be a global utility. And as part of that initiative, we want to be compliant with all laws and regulations. So every country is comfortable using us. As part of that, we want to be compliant with laws around right to be forgotten, like GDPR. And to be compliant with that, we have come up with this transaction author agreement, which is like an end user's license. It's something anyone who wants to write to our ledger needs to be aware of and agree to, that our ledger is immutable, and when you put something on our ledger, it's there forever, and anyone can go into the history of our blockchain and be able to dig it up. So if you're able to hide your phone number in a transaction attribute, your phone number will be on the ledger forever. Or more importantly, if you create a DID that represents yourself and that you own, when you publish it on our ledger, it's public and it's in the public domain forever, right? And so the transaction author agreement just outlines this and describes in detail the rights around it. And that is actually placed on the ledger with a digest. And so every author who wants to write to our ledger has to agree to this and append to their transactions a declaration of accepting this license. The list of accepted mechanisms are also on the ledger. And so a end user has to use one of the accepted acceptance mechanisms. This blog post outlines some of the ways you can accept. Among them are a click agreement, so every time you go to write to the ledger, you say, yeah, I agree to this. Or a session, every time you open up your app, you're greeted with this, and you go, yeah, I agree, I understand. All transactions are final. And there's a contract. There's a few scenarios that this blog post goes over. And there's actually details if you scroll down.
My favorite one is the contract one, where just by using an app, you signed an agreement with the person who supplied the app. That app just goes through it for you and takes care of it all. Because you signed this agreement at the beginning, when you download the app or whatever, then you're done and you don't have to worry about it. But the app itself has to worry about doing it properly, but you don't have to as an end user.
Right. And in this blog post, there's details on how to set up this in a local ledger on your computer so you can test. And some warnings for correlation on best practices around that. And we're actually changing in, I believe, the most recent release. It's
already changed, yeah.
One of the concerns was we had too detailed of a timestamp on, I accept this at this moment in time down to the second, which was a large correlation point where someone could correlate you across not only a DID interaction, but across wallets, potentially.
DID is a digital ID.
Decentralized?
Decentralized.
Or, yeah, I always confuse it. Decentralized, distributed identifier. Yeah. Yeah.
I come from a telephony background, and DID means something else.
Right, yeah. Yeah.
Direct and
Yes. Thank you. That's a great question. Ask more of those because I make too many assumptions. And so the timestamp was a concern of correlation. So in the most recent code, we've actually changed that to be more general, I think down to, is it a month? A day?
It's a day.
A day.
Yeah.
And so the ledger will take and check that your timestamp is actually in the right agreement and that your the digest of the agreement that you agreed to is the same right. And that's part of actually having a valid transaction.
That means if you agree to it, you have to wait till the end of the day before you can do anything?
No, it's very quick.
It sets it up as the very beginning of the day.
Right. And so there's a lot of questions around this and like, how is this implemented? Like if this, then that type of thing. And so it's good. I always want to note that this is really a frontier. We're innovating. I think we're the first that I know of to try and do this sort of agreement on a blockchain. So yeah, it's great fun. Anything I missed? Anyone want questions?
No? Okay, thanks, Adam. That is the blog post.
Actually, is there a mechanism in there where these terms might change in the future and you have to re-accept?
Yes, so the transaction author agreement has a version and I believe another updatable field. So when a new agreement is placed on the ledger, that the actual text of the next version is placed there and a version number is incremented. And that's part of the digest that's created that you agree to. And
what happens if you accept the old one but don't accept the new one?
If you accept the old one, the ledger will see that and say you're accepting the wrong one. This is
Well, no, but I mean, you did that in the past.
Yeah, so old transactions can be accepted with whatever agreement is current time they were accepted. Try to submit a new transaction or an update to existing data object on the ledger. Out using the current transaction author agreement, they would reject that transaction. And part of the reasoning here is when you're making these cryptographic commitments to the ledger is we're trying to make so that as an issuer, verifiers and holders can have and validate those credentials completely independent of you. So you're making that commitment to the public ledger so that others can rely on that data over time. So signing the transaction author agreement is saying the ledger has a justifiable basis for keeping and retaining that data under the various regulatory environments you have to operate in globally, GDPR, California privacy law, or whatever else. That way, when someone goes back and says, hey, we don't want that data on the ledger, you can say, they agreed to post that data to the ledger under the following conditions. And so we can retain that data on that basis. Or likewise, you can say, no, we can show that they violated the transaction author agreement. They posted data that belonged to somebody else. Shouldn't have been on the ledger. And then we have a justifiable basis for redacting whatever needs to happen on the ledger in accordance with not just the technical governance, but also the business and legal governance because they signed that transaction.
good question.
Okay, so now that we have a basis for what the TAA is, Transaction Author Agreement, I'll show you the document that I wrote, this TAA for the CLI walkthrough. This is not, the caveat is this doesn't have anything like what was in the blog post. You saw some code in there of how to use it in code. That covers kind of the code side. This is how you set up your CLI, the Indie CLI, to be able to use the transaction author agreement. It also covers how you set up your local network. That's what this first step here is. So the first step here is to determine appropriate acceptance mechanisms for your network. And what we mean by acceptance mechanism is what Adam was just talking about, either the click agreement or the one-time thing through your vendor or whatever. There's a couple of different ones. This example here actually shows those things. And so you see the product EULA or a service agreement. Right at the end here, when Adam gave me this command, it didn't have this thing called click agreement. So I went and added that myself because the CLI, the Indy CLI defaults to using the click agreement, and I needed to test this stuff out. So I think it's this exact command that I put onto the BuilderNet to send transaction acceptance mechanisms. This is AML, stands for acceptance mechanism list. So this list of acceptance mechanisms went on the ledger, and this context is a link to the active acceptance mechanism. It says AML, but it really is the agreement that it's pointing to here. At the time, there's a different one that they're working on. It's going to be the official one that goes on the mainnet. Mainnet doesn't have it there yet, but the BuilderNet has this acceptance mechanism or this acceptance agreement on it right now. And essentially, whenever you connect to the BuilderNet pool or to the pool after you've run this on it, it'll say, do you want to see the agreement? You click yes. Do you agree to the agreement? After it shows it, you click yes again, and you're in. So, but to set all that up so that it works properly and uses that acceptance mechanism, that's what is under this enabling the TAA and your Indy CLI covers. It's pretty simple, and these instructions make it a little more complex. I'm going to skip back to the to this guy here and go to the next slide and talk about it from here. Again, that one has more details in it, what you'll need. We'll give you the high level here and continue on if that's all right. So you'll need to create a CLI config.json file. Doesn't matter where you create it, because you'll tell it that's where the path is here in the second thing, wherever you create it. And all it has to have in it is the acceptance mechanism for the CLI. So you create this config file, put this one line in it, and then when you start the CLI, instead of just starting with indy-CLI, you add this config file to it. And that's all there is to it, to do that whole setup. Do you guys know what the CLI is? You're familiar with what that means, what the Indy CLI does for you? And maybe I need to go back just a little bit and explain why I keep saying CLI.
It's been a while for me. I think I'd benefit you.
Essentially, the CLI is a administrator's tool for the most part. It's the ability to manage a network and run commands against the ledger from a command line interface. So it looks like it's a command line. You just type in command. So you start up the CLI. I think we had back here inside the other thing, we had a ledger command that we talked about, right? Ledger is one of the commands. That means you're dealing with the ledger. You have to deal with pools, open up pools to connect to pools of nodes that are the networks I'm talking about. You create a wallet inside of the CLI, and you can deal with your wallet from within there, and you can then in your wallet are DIDs and payment addresses for the test token type stuff, and your secret keys are all in your wallet. So Indy CLI provides a way to do that. Most end users, I've heard, will not be using the CLI. Most end users will just have all that stuff through their agent. So, any questions about any of that? And I covered it really quick, but that's why we're talking about Indy CLI, because when you're building your own network, you'll manage it and run it and everything through the CLI. And since the BuilderNet network has the TAA stuff on it, and our other networks will have it on there, you want your local test network to have it on there as well, so you can test to make sure you're testing against the stuff that you'll be running against when you get to the big time. Okay. That's all I had for TAA, the Transaction Author Agreement. Any questions about that before I move on?
One thing to note about the transaction author agreement is intended that whatever products you're building on top of it would have some mechanism for user agreeing. So when you see what options you were set in that config file, you would set whatever options are appropriate for your product. So in some cases, you'd be agreeing because it's part of the EULA of your software. In some cases, because it's part of the service you provide, they agreed as part of signing up for the service. In some cases, you would present the agreement to the user and they click agree. That's really what that tool is for. Is you'd be able to say, the user has accepted this, and here's how we're proving it makes sense.
What's the gotchas? What are the difficult points?
One of the gotchas, I guess, that I've had is forgetting to put the -config on the path. When you get into the CLI and you connect to your pool, it'll ask you to view it and show the thing, even if you haven't put this on your path, right? It'll ask you to view the transaction author agreement, and you can click this, yes, and you think you're all good to go, and then an error shows up. And I go, what the heck? Why is it not working? And the error message wasn't very clear. Put in a ticket to try and get that more clear, if I remember correctly. But why is this all broken? And so it'll still show you the agreement and all that, and have you accept it. But then underneath, the CLI doesn't have that configured to send the acceptance mechanism has to go with the the transactions where you're writing to the ledger. That acceptance mechanism has to go along with it, and until you put this on your, on your command line, it won't send it with it. So that's one little gotcha, and that makes you think like you're actually working with it, but it hasn't accepted it unless you do it the right way.
That burned us. I remember. We have BuilderNet, StagingNet, and MainNet. So BuilderNet's like the dev. I'm going to go test this idea. StagingNet's like, I'm going to set up a production-ready demo. Then MainNet is the real thing, right? Production. So we were playing on BuilderNet, which has a transaction author agreement, a few other things. And we were getting invalid param 6 error.
Yeah. What?
And what's param 6, and 10 minutes later we're looking at code, transaction author agreement isn't.
Yeah, we didn't even have 6 parameters, and so we're like,
Yeah.
what? Okay.
So, yeah, that was a really big burn. Yeah.
Or is TA acceptance mechanism, is that a fixed enumeration of types, or is that?
The idea is as a governance process, technical governance board came up with a list of here's the mechanisms we think we can accept for being able to allow this agreement to happen.
And how many of those are there?
I think there's like, what, 6 today? 5 or 6 total?
And are they
Yeah,
all
5 or 6.
explicit actions by the user, or some of them are implicit?
There are things that the user would have had to actually do. So we ran it by the legal counsel.
So they're kind of they opened the box.
Pandora's box.
Like, are there implicit ones that the user, just because of, like you mentioned,
All of them right now are fairly,
is it-
concrete. It's something that they had to have seen and clicked the agreement, and then the differences are when they saw it.
Okay.
If you have a mechanism that you think should be added to the list, we're happy to have you propose it, and we would consider adding it to the configuration of the network. Basically, it's a part of the configuration of the network itself to say, here's the list of mechanisms we can accept, and here's the list of agreements we will accept against them.
Yeah.
Yeah, the link from here, the walkthrough, has that list of stuff that we currently accept.
And
Like
I expect that list will evolve, right?
Yeah.
Like someone will, come up with a legal case in Germany, and we'll have to remove one. And, someone will propose a new thing to replace it, but that doesn't bound to happen.
Yeah. Another gotcha, when I was setting this up on my personal ledger, you have to put the acceptance mechanisms on the ledger before you put the transaction author agreement. Because if you put the transaction author agreement on first and there's no list of accepted mechanisms, there's no way for you to actually accept what you just put on. Hopefully, I think it forces that order, but that was another gotcha. That's all the gotchas I
Guaranteed before you put the watch.
Yeah. Make sure that your garage key is in your pocket before you open the door.
Yeah, so Adam had that issue because he was doing it in code, right? In the code, you have to do the one before you do the other. The CLI took care of that for me. I didn't run into that issue because when I was telling the builder net to have it on there, I had that context equals at the end, and it added both the acceptance mechanisms and the agreement at the same time. So. Okay, I think we're ready to go on to Auth Rules. Background on Auth Rules. Someone became concerned with the governance of our network when they noticed that a trustee, well, 3 trustees were required to do a couple of the really serious actions by default on our main net, on all of our networks. And somebody said, well, one trustee can create another trustee. And so why are you requiring 3 trustees to be able to do this other action, right? You can just create as many as you want, and, you know, yeah, we trust our trustees, but that's a security concern. A trustee goes rogue, or one trustee loses their keys, you know, better, more likely scenario, loses them or gets them stolen, and then one bad actor can govern the network, right? Take over and do all kinds of stuff. So he said, we need to stop that, and they came up with this thing called Auth Rules. So these rules are how many signatures of what type of role does it take to do certain actions on the network. And so the default auth map rules is linked to here because we have that's kind of the thing that shows us, you know, I don't know why it's called auth map rules. It's an auth rules map, really. It tells us what the different auth rules are possible on the network, what kinds of things can we restrict from happening, and there's about 50 or so of these things that you can, you know, things that you can, most of these are rights. These are the different rights that you can do to the network with different capabilities. See how a lot of these transaction types here are all NIMs? All of those are writing a NIM to the ledger, but you know, what was the state of the NIM before you wrote it, and what is the role that you're going to add in? All those variables come in, and so this really is just write a NIM, right? There's not that many rights. You can write a NIM and an attribute, a schema, a cred def needs to be renamed, and then revocation registry stuff, and then you can do stuff with the nodes where you do pool upgrades. There's just, you know, a handful of different things, but there's all these rules because of the different states that things might be in. So this is a little bit hard to understand, which is why I brought it up. Essentially, the way to read this in English is to add a NIM the role, what does the role mean? Add a NIM with a role where the previous value of the role was nothing, didn't exist, and the new value is going to be trustee, it takes one trustee. So this is the default. When you set up your network and you don't set any auth rules, your local network I've been talking about, brand new thing, this is what the auth rules will look like. This is more English than what you get if you do the command ledger get auth rule. When you do ledger get auth rule, it looks a little bit different. I wonder if I can show you that really quick here.
This makes it so that the security architecture of transactions is no longer code transactions, it's all configurable on the ledger, and we can do with the validation of transactions as a multi-signature verification. It's not a mixed signature or a multi-sig verification where you keep the signees anonymous. It's just transactions itself saying I need to have 3 signatures from valid trustees before all accept.
Yep, where you can write to the ledger how many signatures do you have to have of what kind. So get auth rule here, I'll show you that output really quick. It shows the NIM transaction I was talking about with the different fields, and then it gives this gobbledygook over here that says, it takes 3 trustee signatures. The role here of 0 means trustee. So this is, not as readable, but it tells you how it's set up right now for you on your own ledger. And then this tells you that this is what the default is. If you want these rules to be like the ones that are on the builder net or the main net, then you need to run the run some commands in the CLI to set those up. And fortunately, we have a batch option in the CLI where you run the CLI, you do the -config if you set up the TAA, put that config file in and then put a file after that. It'll run all those commands start to finish as if you had entered them in one by one. And so that's what this is an example of at the end of my walkthrough here that I've created, is the you have to open a wallet and use a DID and connect to your network before you can do any of these things. And then this is just a series of all the auth rules commands that I used to set up the builder net, main net, whatever. So yeah, on the builder net, I don't require 3 trustees to be able to change my auth rules. I'm testing it. I don't want to go and have to find 2 other trustees to sign my transaction for me every time I want to make a change and try things out. So in that sense, it's not secure anymore because there's one transaction that allows me to change all of these guys, right? So I think that's enough of a high-level overview. If you have more questions about auth rules and stuff, just know that I can help you with that. But this is an exhaustive list of all the auth rules and how I set them. And one thing we'll get to in a minute, you may notice here, is that we have inside of some metadata fields, there are some fees. And we'll talk more about that in a minute. I just want to bring your attention to it so that as we do some token testing, the fees also go into these auth rules for how much to charge for things. Skipping back to the presentation here. Okay, so that was, that walkthrough has some detailed instructions on what you need to do to set up the auth rules on there. I added a slide here that I've kind of already talked about, but we'll quickly show you the mapping here between the actual rule and what you see in that table that I showed you. So the transaction type becomes here, right here, this TXN_type. The things that are these first 4 items, 5 items, are static. If you have these 5 items set like this, it will update the rule in the table that matches that. inside of your network. You can't add new auth rules and create new stuff. These guys have to match, and so that's what these fields are all for, is to determine which one of these from that table you're actually trying to update or change. So nim action add field role old value is the same as previous value. Actual parameter is old value instead of previous value, and then new value matches. And then this 0 here is it's the number. I have to pass the number in. They don't have it set yet to where I can pass in the name trustee. And I added something on the next slide here to show you what the different role numbers are. So you got an idea of that if you need it. And then I listed where I got those numbers from.
Here that the numbers that are single digit come from the Indy quantum code base, and the 3-digit numbers come from the Indy code base.
What's the previous value used for in the auth rules?
Is that just an integrity check kind of thing, that you'll only change it to the new one if the previous was
You want to make sure that
Yeah.
you're affecting the rule you expect.
So is that for the auth rule, or is it for, like, when I update a nim, I could say the previous value of the nim had to be?
No, I think it's set.
No,
I think
it
it's
is
just
exactly set.
when you're setting the rule, right?
Yeah.
Okay.
And so there's a difference, there's a subtle difference. There's actually 2 rules for setting a nim. One is you've added a nim to the ledger with no value, and that's different than adding it to the ledger when it didn't exist before. So that previous value is static, and it has to be exactly as it is in the table for you to be able to do it.
So is this
Because there's a
previous-
difference between upgrading a nim that has nothing. Some of the rules, upgrading a nim that has nothing and adding a new one requires different permissions.
So is this previous value for configuring a new auth rule, or is this a previous value for the transaction type? Do you understand my question?
Not really. You cannot create a new auth rule. There's no such a thing as creating a new auth rule. You can change the number of trustees or signatures needed for existing auth rules only. That's why we have that auth rule map. It shows all of the auth rules that are possible, minus a couple. As that gets outdated, there'll be a few new things added.
But I guess for his question, previous value really has no relation to adding a new trustee, the action of adding a new trustee. Previous value only has meaning when editing the auth rule. Is that right?
Yes.
I think it's the opposite.
Yeah, so I guess what he's saying is that it really is almost just like a where clause where previous value equals whatever. In changing or editing the auth rule, previous value doesn't really have any use or purpose when you're actually performing the action to add a trustee in this example.
So when you update an
That's true.
auth rule, are the previous auth rules used to restrict your auth rule update? I think
There's
that
only
boils
one
down to the
auth
question.
rule that affects adding an auth rule, and that is the add auth rule. That's when I said where I kept it at one
Right.
trustee, so I didn't have to
So
on the builder net. So I didn't have to ask.
previous value would be a transition state for the actual transaction value changing. It's not a transition state for the actual auth rule, right?
Correct. So I think this is adding a new trustee. Promoting a trustee from something else is a different auth rule. So
And
the
if
previous
I were
value
to-
would be different for that auth rule.
If I were to read this auth rule, I take it there's some way I could display this auth rule. It would only have a single value or a field called value. Or does the auth rule retain somewhere when you're storing it? Does it actually store previous value and new value?
Well, so
The auth rule
with the
itself,
ledger, you always have all the transactions that occurred backwards in time.
Yeah.
So you can go and look at what this table of rules would have a valid change in the Auth Rules to accept. It posts the change to the ledger, and then the config state is updated to reflect.
And when that's posted there, does it just have value, or do you actually store new value and previous value on the blockchain?
I think it's for a conditional. When you're changing a NIM from any value to trustee, right? So that would represent that condition.
This is what the Auth Rules actually look like on the ledger. Those 5 things that I told you were the identifier things for the rule. This identifies what that rule is. That's all that previous value is for saying, you know, where are we at? Which Auth Rule are we looking at, right? So this Auth Rule has a previous value of nothing, right? So this one is editing a NIM that was of.
So you're basically saying it's a little bit like an input-output address in Bitcoin or Ethereum. You're saying, I want to affect the state that was set on this prior transaction, and I want to replace whatever that prior transaction was with this following condition.
And I take it then again, if I put in, instead of an asterisk, instead of a wildcard for previous value, if I put an explicit previous
You're
value.
saying I'm replacing that particular entry with this string. And the star is for I haven't set something. I believe it's for you haven't set something yet previously.
A wild card, I'd guess.
Yeah,
like the
you're
regular
basically saying
expression.
don't go look up the previous state because I just want to affect whatever state is. We should clarify that with with Alex.
That was constructive for me, at least. So thank you for indulging.
No worries.
It feels a lot like the payment transaction address that we'll see later.
Yep, if we get that far. We are sitting at about 45 minutes of me talking so far here. We still going strong? We good? Okay, let's.
Lunch is ready when you're ready.
There's dogs.
I think that's all that I had as far as slides for Auth Rules. So to recap just a little bit, the reason for setting up Auth Rules on your test network that you're testing things out on is so that it matches what we're doing on our stuff, and you're accustomed to it and know about it. Know that those things are going to happen. You try and do some things that's going to affect mostly administrative stuff, right? Mostly administrative rights and things. But knowing about those Auth Rules and how they're set up is helps you understand the network and how it works a little bit better. So, any other questions on Auth Rules? So is it a good time to grab some lunch and eat while we keep going through it, or should we finish it?
Yeah,
up?
I think that's
let's have a good. Let's have a little break here. I'm going to pause our. See if I can figure out how to pause this. Go ahead and grab some food, and then when we all get back here with our food and ready to go, we'll continue on with the token part.
Right.
How do I pause the recording here? Yep, thank you. Okay, we're just finished pausing. We're continuing on. We're in the test token. It's part of our presentation. Let's screen for a long time, so we're going to go straight to the test token walkthrough and start talking about what are the things you have to do to set it up so that you can have tokens on your local test network. So to start with, the CLI has to have libsop token installed on it. There's instructions here. We'll bypass that. Let you look up that on your own. It's pretty bit straightforward. Then when you start your Indy CLI, there's two ways that you can load the plugin. One of the ways to load the plugin is to do it from the command line like this. The other is to add a another line to your CLI config.json file that we created earlier for the TAA. And now over here it has that. In the TAA walkthrough, I list that the syntax for that plugin's line, so that the plugin is automatically loaded every time if you use that config file. That's the best way to do it. But I have the command here in case you hadn't set it up that way. In this walkthrough, I probably should include that other notice here. Do it from config file. Like I said, these things are all kind of new within the last couple of months, and so these walkthroughs are in progress. They're rough draft, I guess, is the best way to put this. Kind of as we go along, we'll add to it, and if you have comments about it, just put them in the comments over here on the side, like this comment over here, and we'll enhance it so that everyone is able to use it better. So the purpose for tokens is so that there's a method for paying for usage on our network. The testing part of this is all free. There's no charge for anything on the builder net or the staging net. So I should say it's one of the purposes for the tokens. The initial creation of tokens on your local test network is called minting. So that's the first step in this walkthrough, is to mint some test tokens so that you can have them available for use. And that's not something that I want to go through. There's quite a few steps there, and it's not too hard. There's not a lot in here that needs explained, except maybe inside of the library underneath. One token is actually 100 million what we call Sovatoms, or Sov atoms if Adam's in the room.
Right.
Then the there you go. So the fees that we're charging actually have that in a background thing I noticed earlier. These are the fees that are on there. You see how they all have 8 zeros after the actual number of tokens here? And that's so that we don't have to carry decimal points or anything on the ledger. It has a, down to 100 millionth of a token is so that you can actually share around. But the cost of things is in tokens, so we have this add 8 zeros to the end of all the commands as we send them to the ledger when we using the CLI. So that's something to be aware of.
Again, remember, these calls are optimized for the ledger to be efficient. We expect the wrapper libraries will handle reconciliation of soft comps and how inputs and outputs those things will happen. So when you walk through some of the ways some of these transactions work in the CLI, they're designed around how the ledger operates. When you go into the framework code and the agent code, that's where they should translate to define how the end user will operate against.
Yeah, and I've heard there's apps that tell you to toss this many tokens, and you don't ever see it if you're an end user with a phone app that has, here's your wallet and here's how much it costs to do things. It converts it all for you. So that's obviously, right? They're not going to tell you it costs 100 million.
It's like trying to understand your Linux system by reading all the systems.
in trying to understand this, this is just for the test tokens that I have this ability to just mint them out of thin air.
For your network, you as a trustee,
Remember the Auth Rules table?
you can mint them. Yeah.
You can configure it so anything can mint. So that kind of defeats the purpose of using it for spam prevention. So in the case of the live network, you'd say 3 trustees have to sign it.
And then those tokens are tied to my network only.
Right.
So other people would have theirs.
That's right.
So I could create some new firmware for some of my old AND miners and claim that they're sovereign claim miners.
But they would be sovereign.
All they do is be calling the mint API to mint them.
Theoretically, yes.
I finally have a use for those old.
Just like anyone can install a MySQL database, but it's their data in the database is important.
Yeah.
The sovereign token is on the live instance of the sovereign network, not that you're running the sovereign token.
So the sovereign tokens, the test tokens that are on the builder net are non-transferable to the test tokens that are on the staging net, and they have nothing to do with it. Any future possible tokens that might be on the main net. So,
But on the main net, once in reality, off the test net, this same capability exists.
yeah.
It's all open. Anyone can use it. They'll use it how they see fit.
Okay.
The tokens
Awesome.
are all sort of theoretical at this point, right? Like, they're not actually on the main net.
They are not on the main net. We're testing with the idea in mind that they might be.
You'd have to go through the whole governance process around how to mint that.
The token plugin is installed on mainnet. So the token or the payment ledger is initialized on mainnet. But we haven't done any token.
Yep, no minting yet. Yeah, and now we're talking about how to manage payment addresses for the real tokens, but we're going to tell you a little bit about payment addresses here in a second here and explain how that works and how that gets in your wallet and that kind of stuff. So, so once things are minted, you can start transferring tokens. I think before we do that, though, I'm going to talk a little bit more about set fees. This kind of came as an afterthought here. We'll go back to where we talked about that a little bit in the Auth Rules. Remember in the Auth Rules, it had for a token transfer, it was transfer underscore token or something was the name of what was the name of that thing that we looked at in the token underscore expr as the fee that was being charged for this action, this write action. There's 8 or so different fees, and I decided to make an alias for each one of those different fees for our purposes. And so if you want to match what's on the builder net right now, you'll use the same aliases, and you can use that same file that I just showed you, the one where I said you could a batch run all those Auth Rules commands, and they kind of go together, so that how much that token underscore expr is right here in the, this is, this is actually a different network. This is the staging net, but it matches what's on the builder net. So this token underscore expr is an alias. The underneath it looks up and says, oh, you said it's token underscore expr. Let me look at the get fees table. This is the table. And it says, oh, that's 1 token. And we can count the number of zeros, 1, 2, 3, 4, 5, 6, 7, 8, just to double check if we wanted to. And so this is kind of hard to read because of the 8 zeros after it, right? But for a cred def, it costs 125 tokens. For a schema, it costs 250 test tokens.
And this is the fees that are set?
These are the fees that are set. And so there's a set fees call. We'll go back over to that. This set ledger, set fees. And it says set fees prepare here. Because what happens when you set fees is, guess what? By default, it takes 3 trustees to set the fees on the ledger. And so since I didn't change that set fees on either the builder or staging in, I have to go find 2 other trustees, 2 of my buddies. I think Adam might even be a trustee now. but they find two of my buddies, and I do the set fees prepare, and what it does is it returns the transaction, and then there's a ledger sign multi that will allow me to sign that transaction. So I run ledger sign multi on the transaction return from the set fees prepare, and I pass it to Adam, he signs it, and I pass it to another trustee. Who's the other one? Matt Norton is another trustee. He signs it, and then we're ready to send it with a standard command to the ledger. So it has to go through a couple of different things, unless you know enough about Auth Rules to go and change the Auth Rule that sets that up. And let's see. Oh, we can make it so that when we mint, it only changes 3 to a 1. So one person could mint on your ledger if you wanted.
This is why it's important to pay attention to all your Auth rules. So you don't want someone to be able to change the rules to bypass your
Oh, here's the set fees. So we can say, you know what, I'm tired of having to pass that around to other guys. I'm just going to do a sig count of 1, sign it myself, and I'm good on my own ledger, right? That's another caveat, a warning I forgot to tell you about. If you do the Auth Rules as listed in this thing here, I did take the added precaution of not doing the Auth Rules one at the end. That's a set thing that I do after I run this batch script. The last one is setting the Auth Rules so that when you change Auth Rules, it takes 3 of them. By leaving that out, the default is 1. So if any of these have an error as I'm going through, I can rerun it again and fix it, right? But if you set that up in this way and then change it and so that you have, it takes 3 trustees to do a bunch of this stuff, but you only have 1 trustee on your test network before you do that, then you're in trouble. So either add more trustees so that you can try this out, or change a bunch of these 3 trustee things to be just 1 trustee for your test environment. So it's a good thing I remembered that one, because that's a big deal.
And just to clarify one thing, when you guys use the term network versus like ledger, can you clarify the meanings, the definitions of those terms?
That's a good question. And when we say the network, we mean the nodes that work together to create the consensus that is for the ledger that is on the network. Does that make sense?
Okay, so
ledger
if
is
this does ever get implemented on the production Sovrin mainnet, there would only be, one set of fees defined by Sovrin on the mainnet.
Yes.
And there is one Sovrin token. That's it.
Yeah. In fact, if you go look at the mainnet now,
Yeah.
you can go get all of the Auth rules. You'll see that these are set up for permissioned access. And the token plugin is installed, that is initialized, but there are no token fees set.
Okay.
So you have to go through the permission channel. There is no permissionless access currently configured. But all it would take is to go and update the Auth rules, mint some tokens, and give them.
So we currently enforce fees right now with fiat or regular currency, regular money, right?
Yeah.
So if you want to sidestep altogether, if or when it is, you can.
So the idea being now is if you're going through the permission channel, you have to sign up to be a transaction endorser, which means you're a known entity. We can count how many transactions you wrote to the bill.
Yeah.
But if you have the permissionless write access turned on, you can go acquire tokens from wherever you want to. You just come say, hey, I have the right to write this to the ledger. You sign a transaction author agreement. You can see that transaction, and I paid for the transaction because fee is included in the transaction itself. It doesn't matter to us who you are, it matters that you're following.
All good?
Yeah.
Okay, so we jumped back and forth a little bit because of that thing I forgot. And we're jumping around a little bit, but essentially setting the fees makes it so that you can charge yourself for transactions on your test network and try that out for the future, for when you're ready to go live on one of the other networks. So next step is to make a payment address. Let me cut back to my my thing here. Not spending a lot of time on this PowerPoint, but I think we might a little bit. So there's the set fees for the different kinds of write transactions that we charge for. And so far, really, this is all. I tried to name them as if they were, you know, so you can tell what they are and what they're for. And this is all that we charge for right now. And the fees are changeable. We have a you know, board of trustees and a TGB, technical governance board, and some economic advisement committees that work with the foundation to make sure we're doing setting the fees correctly, et cetera. And it won't be very often probably, but these are subject to change. And so you have to know what the fees are. You have to do the get fees command that I told you before. Make sure you're doing that properly. Before you can really do anything on any network, you have to create a payment address. The payment address exists in your wallet. This is your own secret private thing. So you open up your wallet and you're inside of the NDCLI, and I just barely made that slide, so it should say NDCLI on that first line as well. I made that slide during lunch today because I realized, you know, based on what Nathan said, I'd forgotten the payment address part. It's important to have a payment address. So we've added that here. So the command is payment address create, and you put in payment underscore method equals sov. And one other thing that you can do, and that you, the other thing that I did for the BuilderNet and StagingNet, because you know, if you ever lose this wallet, this goes away. You don't have anything to get this back, unless you add a seed parameter to it. If you do a seed equals, and then 32 characters of a seed at the end of this command, then that payment address is recreatable in a different place. So now your seed is super important, because if somebody gets that seed and knows that it goes to your payment address, they can put that payment address in their own wallet and take your token, right, essentially. So that seed is super secret. It needs to be something you guard carefully.
The key is super secret too.
Yes, but the seed creates the key.
The seed.
And so if you use a very simple one and someone decides they want to mine tokens on our ledger, what they would do is just start generating addresses with seeds of, you know, simple phrases or whatever to try and do a collision with your address. So that seed really is
So the seed will always create the same key.
yes.
Yes, the seed will always create the same key. If you lose your seed, you're okay as long as you don't lose your
It's gotta be
wallet.
something smaller than a seed that generates the seed.
Huh.
I like this idea.
So,
Get to the decentralized key management discussion.
Exactly. No, so all I know is this last week I was so happy for paper wallets. I had an iPhone die. My wallet on it for Bitcoin.
yeah.
And I started to freak out. Luckily, I still had a paper wallet with the key on it.
But I mean, it's important to point out that this is the infrastructure with the ledger has consensus and it can help you. You have your own cloud of agents. You have all of your contacts that you can use to manage. You have credential issuers and verifiers to deal with it. And then you can also then build different types of escrow services for Canada. Because you have cryptographic keys that can come pairwise way with each relationship. yes, it makes the key management worse on a one-to-one communication level, but it changes the nature of key management from I've got this super key that I have to protect with everything to being about all the relationships collectively, just like it is. Right? If your business people stop recognizing you, then at least your family still recognizes you, and kids' sports teams still recognize you, right? You have multiple aspects of yourself. Whether they'll all cooperate in your recovery process, that's a whole different question.
So payment address is just an address, the secret key that sits in your wallet. Doesn't necessarily mean that you have any tokens yet, right? So to get some tokens for the builder net, your test tokens for the builder net or the staging net, you send an email to me, support@sovrin.org, and send me the payment address that you created for that purpose, and I can transfer some tokens to your wallet, okay? And what does that do? Well, in the background, if you're interested, the ledger itself actually has the tokens on it and keeps track of it. There's a separate ledger. And you don't want to go into the multi-ledger things, but it's part of the network. So it's safe to assume that it's all part of the same thing. But there's a token part on there that contains and keeps track of all of the tokens and the transfers and all that stuff. And what happens is you get a, what's it called? Source address? Source. So the source will be associated with your payment address when someone transfers stuff to you. So and say I'm the master here and I want to transfer some tokens to your payment address. This is all the new way of doing it. It used to be that you had to do a lot of math to figure out how to make the CLI work, but this is all super cool now. Adam may not have even seen this part yet, where you have a source payment address, which is the, my stuff that I'm saying I'm going to transfer to you, and this is your payment address I'm transferring to, and I'm going to transfer 100 tokens, and the fee is 1 token. So I'm not sure why there's a fee equals here, because and I asked that question as I was building these slides, because I was like, wait a minute, isn't the fee already out there? Don't they already know what that fee is? So I think eventually that fee equals will go away, because we can't change what the fee is.
Does it say Bitcoin?
Why would we have to list it there?
Change, your request, your offered fee, and it'll change the priority. It'll decide what miner chooses to actually process the transaction.
Yeah.
But if you guys aren't doing that,
no, those fees are set on the ledger thing.
charging
And so,
Well, because it's a permission network, there's not an unbounded scope of validating those
it's
messages.
going to process.
And so the bandwidth of the network itself is effectively null. So it doesn't make sense to have an elastic fee in a sense. The fee is really a spam prevention technique, not a market driver.
anyway, so right now that fee equals parameter is there. Why it's there, I'm not sure yet, but I'm looking into it. So, but here's the amount that we're going to transfer. And so what this transaction does is it takes one of the sources, or multiple sources if needed, from the source payment address and says, I need to split this between this guy and whatever I'm transferring to minus the fee. So it takes out the fee and then makes a new source with 100 tokens in it and assigns that to this payment address, and then makes a new source. Again, the old source disappears and we're splitting it, and then the new source with the remaining tokens goes back in the source payment address.
An initiator always pays the fee.
Yes, I believe so.
Transaction that they collect.
Someone has to prepare the payment section of the transaction.
The initiator is always going to pay the fee. So
I believe it's possible for someone else to pay the fee for your transaction, but I don't know if that's
the recipient. Force the
Well,
recipient
before the
to pay.
transaction post, someone has to put a valid payment on it.
So the actual transaction has a list of inputs, which are the payment, are those the sources then?
Yeah.
The inputs. And then it has the outputs, which is the payment address, or like the public key.
You're talking the old way
I'm
of,
talking the step
of
below.
how it
they
looks on
wrap
there.
this.
Right, right.
So this is the step below. So the amount in fees, so all the changing has to sum up to the total of the input sources. And then after that, you have to have all those fields signed with the private key of the sources. So you would have to get someone's source address on the ledger and get them to sign.
Yeah, so I could say, hey, I want Alex just to be able to do a transaction with my tokens. I could sign a payment portion with my face-off private key. I can say, here, include this payment portion in your transaction.
Right. And so the new sources are unspent coin, unspent transactions, which are locked to the private key of your public address.
And I guess you already get it, because if I were to pay amount plus fee to that person, then they're gonna get the amount. If I only say I'm gonna send the amount to the person, they're gonna get the amount minus fee.
So in the
Yeah, you could
output,
transfer 99 to them,
Sometimes they say all of the
charge
fees,
them
sometimes
100,
they say
you give them
gotta pay
90.
extra.
so in the outputs, you can specify an address and then the amount that goes there. So you can
But there isn't a
how
way,
it's split.
what you're talking about, there isn't a way to essentially push the transaction out there, notify the user, hey, this is waiting for you, all you've got to do is pay the fee.
Exactly.
For that, you could use credentials, right? So Sovrin has this other layer, right, this credential layer. And while we have not yet implemented verifier pays issuer, that's exactly what verifier pays issuer is. So is I'm going to give you a credential, which could have value, right? It could be a monetary credential.
Yep.
And you can't unlock it until you pay this fee. So you'll have it, but you can't do anything with it until you pay the fee. So at the credential layer, that capability is possible.
The other thing that is not far out in our future, once we get through our non-press 2.0, we've been talking about the idea of instead of locking a credential still to your link secret, where it's part of your wallet, it can't be removed from your wallet, we can lock it to a double spend proof registry on the ledger. So just like the payment ledger lets you check to see if something's tied to the right thing, we can check to see if the credential's tied to the right double spend proof registry. And now that credential becomes what we call a transferable credential. And that lets us model both things like the Sovrin token and all sorts of other fungible credentials using the Sovrin credential token. That's part of the future stuff. If you want to help us code on that area of the system, we'll get there fast.
What's it paying?
How many Sovrin tokens?
Cash only.
Are there any more questions on transferring tokens? It's kind of the first thing that has to happen is you send me on your own test network, you can set it up to where you mint to a payment address and then just use that payment address to pay for everything. But transferring tokens is a pretty common thing, and that would add that in here anyway. So, but on the builder net, that's what you have to do. Send me a payment address, and then I transfer some tokens into it, and then you can start using them to pay the fees that are on the builder net. The pretend fees, because I give you as many as you want. Right? We're just practicing the practice fees.
When I send out a virus that encrypts someone's computer system, they can get onto the Sovrin network and I can send a credential which has in it the key that lets them unlock, but they don't get my key back. So I don't have to go out and ban. There's no other network.
Great power, great responsibility.
Practical uses.
Yeah. I'd be just like you would have.
Okay, so now you have some test tokens, and you want to use them as payment. Here's a small example of that.
Look at that. See, you can use a criminal example.
There you go.
We're on a roll today.
So we've got a few things that we charge for. Adding a schema, adding a cred def, creating a new NIM, changing the attributes on a NIM. A few examples of what we charge for, and like it's on the previous slide, we're charging for the transferring tokens as well. So this is just an example to show that from the CLI, this is a CLI command again, all that is needed is to, up to here is the normal command. Oops, I can't highlight it. Sorry. So up to here is the normal command, and then to pay for it with a test token, you just have to add a source payment address on there. And this should not be there. So I apologize for that. We're going to get out and fix that so that you don't have the wrong example here. Sorry, this is a little bit of the old way. The old way you had to do some math and figure out how many tokens you'd have left after the fee and everything. But the new way, they have the CLI doing it for you. Just give them the source payment address, and they'll take the fee from the sources associated with that payment address and repopulate your address with the new sources.
And this particular attribute is the action is doing what? Is it setting that attribute?
It's adding an attribute,
And so there's
to
a
this
fee
did.
to add an attribute. And that's why I'm including the source payment address.
Yep. There's a fee to add an attribute, and that's where this fee comes from, is that guy right there.
If I issued that command and didn't include the source payment address, what would happen if there's a fee? Would I get back an actual error?
It depends on what's on
Yeah.
it depends on what's in the auth rule for it. So let's answer that question with by going through and finding out what actually will happen. That's a great question. It's a good way to look at things and figure out what how this all works together. So what did we want to do? We wanted to add an attribute. So I'm scrolling through my sorry. Control F.
We got 4 of them.
Okay, so this is add an attribute, is what we were doing, right?
Yep.
And this says, oh, look at that. It can be, there's an or constraint here on this particular one. We didn't go into what that means, but essentially we have one trustee that's an owner, so you need to be owner, or one steward that's an owner, or one endorser that's an owner, or one of the network monitor roles that's an owner, or anyone, the star here is anyone, just one, who is an owner that pays the fee. The trib underscore add, okay, is an owner. So the answer is you don't have to pay the fee if you're a trustee or a steward or a endorser or a network monitor, one of the other roles. If you don't have a role, if your NIM is role-less and you're adding an attribute to it, you have to pay in tokens. These other people may or may not be charged based on, Adam talked a little bit earlier about a fiat payment. You still have a payment that you have to pay, but we'll send you a bill in the mail if you're an endorser or one of these other roles that tries to add an attribute to your NIM. That make sense?
Yeah. So that the CLI would kick back an error of some sort.
Right. If you
indicating that that section of the rule failed.
if you had no NIM, then it would say, sorry, you didn't pay the fee. It would fail. Okay. Yeah, that was a good exercise. I think that helped to link all these things together and solidify what we've been talking about. That was a great question. Appreciate it. Any other questions for using test tokens as payment for things? That's pretty much it for tokens, I think. I mean, we're at the next slide was this BuilderNet slide to tell a little bit about what the BuilderNet is and what it has on it. So I'll pause for just a second. Any more questions on the tokens? Okay. So I've been saying it all along, so just stay here really quickly or shortly for a short period of time. Skip down here to the middle. The TAA is enabled on the BuilderNet. Auth rules are set up and functional. Test tokens are all available. The BuilderNet is essentially for vendors that want to build solutions. They go out there first, try things out, get it all working before going to the staging net. Like Adam said, we're run a production level demo or allow end users to come and try it out there because it's a little more stable. This is the first network that's upgraded. We did our best to match it to production. There are some caveats to that. Like I mentioned, some of the auth rules will be a little bit different to make it easier to maintain it. You can try almost anything you want on the BuilderNet. Things that are like, you know, network performance testing or security attack testing. You want to have permission before you do some of that kind of stuff out there. For obvious reasons, you don't want to know time. But it is a worldwide network. All the Sovrin networks are all around the globe. In fact, right now the BuilderNet may actually be the most diverse of our networks. We're working on fixing that so that our mainnet is a little more diverse than it currently is, because only about half of the mainnet nodes are outside of the US. There's literally, I'm pretty sure 3/4 to 4/5 of the nodes on the BuilderNet are outside the US. So that one's a lot more diverse as far as being around the world. And you know, there's other diversity things that we care about on our networks. We care about, you know, AWS. Are they all running off AWS? Are they all running off of the, you know, Azure? Or, you know, we want it to be a mix of the different kinds of things, or, you know, in their own data center, even better. Right? So, but then, you know, this is kind of the final slide. Essentially, you send your, if you want to be, start setting things up and do stuff on the BuilderNet. Right now, you need to send us your DID and your payment address. Yeah, DID and VER key go together, and we can get you set up, and you can start without setting up your own stuff like I just went through. You can start trying some things on the BuilderNet, and that's what it's there for. So, in a little bit, we'll get an upgrade that'll make it so that you don't even have to send us a DID. You just need to send us a payment address, and you can use your tokens that we send you to make your own DID. So, I'm not sure if that was in the last fix or that's next. It might actually be on the BuilderNet now. I can't remember if that was in this one or if in next month's. So it's either this one or it's already there maybe, or it's in next month's upgrade.
I think that'll be an interesting development for people.
Yep.
Just get some tokens and then you can do everything else yourself. Very cool stuff.
Sorry, I got to run in another meeting. I got to get something. It's fun to see all this like kind of coming together and working. Yeah.
Hey, thanks for your patience. Sorry it took so long. It was supposed to be a little faster than that, but
No, that was perfect timing actually.
okay, we'll see you later. There was one guy that came and
More
just
back-end
talked and
ledger,
talked for
infrastructure centric.
2 hours, and I'm like, oh man, this is taking forever, and that's what I just did.
That would be great.
Oh, well.
Can you do another meetup next month?
We don't have a speaker yet for next month, so keep watching the meetup thing. We try to do it every second Friday, but last month we weren't quite ready with this stuff, luckily, because this is way better than it would have been a month ago with the new stuff. Just we'll keep our eyes and ears open, see if we have another speaker. Otherwise, we might skip a month again.
We were
Depends on what
working
we
on some out-of-the-box demos where you can just grab an open source repository and get full credential issues. In fact, every other week we're doing kind of what we call the innovation instance sprint. And let's take 24 hours to see how much farther down a particular use case we can get. So today we've actually worked more on that demo membership credentials for any organization. So, hoping we have some more things to show around some of that sort of thing. Or maybe there'll be a community member who wants to.
Well, I will keep my eyes open.
What topic would be interesting to you? Because the last time somebody said, hey, I want to hear about this, we did one on the next one because we just, we kind of guess at ideas and have new things coming out like this, but then what people are interested in is what we want to talk about. So you got any ideas of what you're interested in and what kinds of things are still too new?
Probably still too new.
Okay. How about you? Got some interesting topics you're interested in? Something you want to hear more about?
Too. What I'd like is getting started.
So we should do get everybody set up as an issuer on
one-on-one.
even if it's just a sandbox network for the day,
Right.
and just start trading credentials and playing around with what we can do.
Yeah, that would be good.
Awesome.
Feel free to take a hot back.
I think I'm good. Thank you.
Yeah, have one every 6 months whether I need it or not.
Yeah.
Hey, thanks, guys.
Thanks for coming, John. Thanks, Tom.